Okay, hi everyone. I'm Artur, and I came from Moscow yesterday, and I'm really glad to be here. Thank you very much. And I work as a lead engineer at Yandex Market, and I'm also a lead engineer at Yandex Market Design System team. And today we'll talk about the ways we can style applications. And to begin with, I'd like to tell you a short legend about the styling Grail. Once upon a time, there is a developer, and one day they wrote the CSS code, and that CSS code was perfect, really perfect. The styles were scalable, readable, efficient. Even designers could read, write, and maintain those styles. It was a miracle. But no one has ever seen it. And hundreds of front-end engineers burned out trying to find the styling Grail, and the holy styling war began. The world broke into two camps, plain CSS and CSS and JS, and that's where we live now. We live in the divided world searching for the perfect solution. Okay, so actually it really looks like the modern front-end development made a dramatically turn to the CSS and JS side, and for the past couple of years there has been a boom in CSS and JS solutions to style React applications. Some of them even could fit in a tweet. This is amazing, and it's really awesome that we've got so many options, right? And I also participated in this movement as a contributor to the CSS library, and I've got a deep dive into CSS and JS. So nowadays we have really many different solutions. We have a lot of libraries. I mean, we have really a lot of CSS and JS solutions, and it's everywhere, and it's not that easy today to decide on the approach to choose. And if you'll take a look on the state of CSS and JS in 2019, there is a huge difference in popularity between CSS and JS libraries. And I think that many developers heard about style components. Please raise your hand if you heard about it. Oh, yeah, really a lot of people. And developers often doesn't even consider any other options. It's really clear how style components trendy today. It's much more popular than any other CSS and JS solution. And now I can say that's it. We have style components, let's go home, all right? But it's actually, there are a lot of trade-offs, and we will talk about them later. But to continue, let's actually look back in the beginning and consider the problems that engineers were trying to solve through the whole time. So the story begins in the early 90s. On the dawn of web, there was nothing like CSS language, and engineers were trying to find the way to style websites at that time. So there were a lot of different and interesting drafts and proposals how to style the application. For example, there was a proposal on scheme language. Could you imagine write styles on the scheme today? But we can also notice here that all of that proposals had the runtime part. And it's not about the static language or the static language that is some declarative or all of that. No, we could write the code here and we can match on the attribute on the runtime, and that's okay. It was okay at that time. If you want to know more, there is a great article by Zach Bloom about the evolution of CSS, but I'd like to focus on a few interesting examples. In the end of the 90s, there was an idea to style apps by styling text, and you can apply some styles to the pages like this, and years later, we have design systems on React, right? And it's so close, and somebody tell me if you've got a time machine. But at that time, styling texts were obsolete, and we don't have them, for example, in HTML5. And it doesn't support them, and we should use CSS instead, for example. There were some problems with styling text there, and the most important, I think, is the problem of HTML applications at that time were monoliths, and it was quite hard to isolate the components and your logic. But with React, we have encapsulation, and yeah, we can rethink this approach in a component way. Another one interesting proposal called JSS by the Netscape team in 1996. It is really interesting because today, for example, we have JSF, and this is the with operator, right? You don't use it, but you can with so it's the working code, and it would work like this, but don't use it in real life. And that proposal was also declined because it was a draft, it wasn't finished, and anyway, we can use some ideas from it, like with JSS, for example. And the last one idea I also want to mention is CSS expressions by the Internet Explorer. it's very close to one popular thing and any ideas. It's about style components. And to be honest, when I found that, it was really, really, really interesting that we have a similar approach. And these expressions were deprecated in the Internet Explorer 8. There were some problems with performance, and it wasn't supported by any other browser, so they deprecated that. But we still have some performance problems with style components. But let's talk about it later. And in fact, if we get back to the end of 90s, the CSS we know today became a standard in web development, and CSS provided new opportunities to the web design. And there were a lot of interesting websites at that time. But developers faced with some pain with plain CSS. And I'm sure that every front-end engineer has spent some hours puzzling with CSS, right? And yeah, let's talk about some pain with plain CSS here. The first one is reusability. It's hard to reuse the CSS code, right? We need to copy-paste for many things. With CSS custom properties, for example, we can make it easier, but 20 years ago, we didn't have that option, so it was really hard to reuse the code. Another one problem is specificity, and the order of rules in style sheet is matter, and the problem is that it's quite hard to maintain that with many style sheets. If you have different style sheets, it's matter in what order will style sheet apply. So, plus all selectors are global, and it might be a naming conflict, for example, in your code, and some unexpected styles on the elements. CSS is declarative, right, but actually sometimes it's quite hard to express your thoughts, some complex things there in a simple way. And as a result, CSS is not really scalable. It's hard to maintain by the big team. And another one point that everyone loves browsers, and it's quite hard to maintain all the browsers that we have. So I'd like to mention Max Weber's tweet here. Please raise your hand if you think that these divs will have a different color. And who think that it will be the same color? Raise your hand. Not so many people, but it's a tricky question, right? And this tweet proves that we still don't have full understanding of CSS. More than 44% of Twitter users confuse the right and the wrong. It's not the wrong answer. It's not the right answer, which is the most popular. The right answer is both do. But yeah, it's confusing, and it's not surprising that CSS is confusing with its specificity. So as a result, many technologies and methodologies were created to simplify the development and organize the CSS code. So one of them was BAM. It's a very popular methodology, and it has various implementations like the code on the slide. In short, we can decompose our code to the three entities: block, elements, and modifiers. It's really important that BAM is not only about technology, but the way how we can communicate with designers and understand each other and use the same language. Personally, I think it was a huge step forward, but there is also a big thing in web development as CSS, because it introduced some variables, mixins, control statements for CSS. So yeah, BAM plus CSS resolved so many issues that we had. It's really important and huge step for web development world, but there are still some problems with BAM and with SCSS, for example. With BAM, you need to know about convenience. You need to know about how you should name your class names, for example. You need to discuss that with your team. So not everyone can understand how you can use that. And build step is also adds some complex to the system, because you need to build your SCSS code. So with plain CSS, you can just write your code in the browser and that's it. But with SCSS, you need to compile it. And the barrier to entry is become higher, because you need to know SCSS, mixins, functions, and all of that stuff. So web developers were still growing, it became more complicated, and many ideas and technologies were created to resolve some issues for huge applications too. And for example, PostCSS introduced a great plugin system, and it created the ecosystem of plugins. So there are a lot of amazing tools built with PostCSS that we use every day, after prefixer, styling, and all of the other great things. And with component error, which is the most important thing that we have, I think, we came to component error in web development with React. And CSS models was also a step in styling components for React applications. So we can just write our styles in a separate file, for example, import that styles in your component, And that's it. Your component will have isolated style, so your class function will receive the hash. So there is no problem with naming. You can just name your button as button, and you don't worry that other developer might use the same class name here, because all the class names will receive the hash. So there is some kind of isolation. Not completely, but it's a bit better. So let's take a look at this code. For me, the markup is really dirty here. It's not super readable, right? I've seen thousands of lines of code like this. It has some mess and some loss of semantics. And I mean, this code is simple, but it will work, but it's quite hard to understand and maintain, and that's why many people still don't really like to use CSS models, for example. Anyway, CSS models plus CSS resolve other problems like naming knowledge and naming convenience. But we are still growing, and we still have a lot of open problems that we need to resolve. For example, it's quite hard to apply some styles at the runtime. It's quite hard to use the style for third parties, because you require to use some build system to work with your library, for example. And yeah, I think we're ready to talk about CSS and JS here. And yeah, style components is one of the most popular things, and it can give us a lot of benefits. It's not just about style components, it's about the CSS and JS solutions in general, but with style components, we can skip our build step because it's just the JavaScript, for example. We can use semantics here, and instead of mapping class names, we can just apply our components, and we will get much more clear our markup. But yeah, another one benefit is that it's just the JavaScript. You don't need to learn about mixins and variables in SCSS, for example. You can just write your JavaScript here, and this is fine. So there are some complex things that you can make with theming, because this is just at the runtime, so you can apply some variables from the runtime and it will work. You can have critical CSS out of the box, because you can just render that styles that you need to render, and you don't need to download all the styles of the whole application. You can achieve some things of universal components. For example, you can write the same code for React Native and React for the web, but it's quite kind of tricky, and it's not really work for all of us, but yeah, it might work. And developer experience is better. Okay, I think it's time for a serious talk. There is an example of the popular project, and honestly, can you read it? I personally find it a bit challenging, and I've seen many times how developers duplicate their logic just because it's not really easy to match your state on the styles with imperative code, imperative constructions of JavaScript, for example. So CSS is really declarative, and you can really easily match your state to the composition of class names, for example, but here it's a bit tricky, and sometimes we need to spend a couple of minutes to understand the code to make a 1-second change here. And there are just a few examples, and I have a lot of more concerns with style components here. And the first one, I think, is performance. There are a lot of benchmarks, and it's important to understand that when you use style components, you will parse and generate styles on the runtime. And I made some small benchmark here with style.js test and emotion. And performance is really has a big difference. And for example, if you need to render there about 1,000 boxes, it's quite hard to style components here. And you can say that, oh, I don't worry about performance because my clients have MacBooks Pro, the latest, and that's fine. Yeah, maybe, but the difference is huge, and the question is, what's your gap? What kind of things you can apply there, and what's the freedom you have with your performance budget? Another one problem is here is combination with composition. For example, we have a button with 4 modifiers and 3 values, and composition will give us about 12 styles, while combination will give us about 81 style variations. What I mean, for example, if you take a look on the website of style components with the official website, so we have 2 buttons, normal and primary. They have almost the same styles, but they have different colors. But if you take a look on the styles on the class on the classes, we can see that they are completely the same. All the difference is just the background color or the text color, but it will generate the same with the same style with the duplication of rules and another one class, and we will have both styles then. Yeah, because you need to duplicate all of your things, all of your states of your classes, and with each state of your component, you will render another one class here. Another one problem is static self-extraction, because, for example, we have a lot of requirements for our performance and for our caching too. So if you cannot extract your styles and save it, for example, in the cache, you need always to render your styles in, for example, your HTML markup when you serve it from the server side, and it will really also bloat your HTML too. And another one problem is imperative mapping state to the styles. I've shown some slides with that problem, because JavaScript is not really functional. We don't have pattern matching. It's quite hard to match your styles to the sum of class names or classes, because we don't have that instrument here. And another one problem is component API control. What I mean, for example, if we'll take a look on this composition of mixins, which is really popular pattern with style components, that's quite hard to understand which the latest API will be with this component. For example, space requires two props like space and width, for example. It also requires some props, and even with the type system, it's quite hard to infer what kind of API my box will receive. Moreover, it might be some conflict between this mixin and this mixin, because they can work with different properties in a different way. For example, space will work with one property space, width will work with another one property space, but they will work in different manner. So that's quite hard to maintain sometimes if you have a lot of composition here. And which is more important, I think, is internal API control. And there is an old issue with style components about the passing of your styling attributes to the DOM. For example, if you have an attribute color, to set the color component, you can't filter that just because you don't know how to filter it. You need to have a whitelist, for example, because in the implementation you don't know what kind of attributes you need to pass or not. So you need to have some whitelists and blacklists, and for example, style components have some kind of whitelist, but it also has a size. So there are really some issues here, and it's still open. And another one, and the last one point here, is element decomposition. There is also a code from a popular open source project here, and we can notice that the engineer was really, it was a bit puzzling to decompose the component to, decompose the component to different elements, and the engineer here used the global class name just because it's quite hard to decompose. And yeah, there are some problems that we can resolve with tools like Linearia or AstroTurf, and we can do with some of these trade-offs. But the side of this improvement is that we will lose some of benefits here, because we need to have a build step. We also can't use a critical CSS. So there are a lot of problems that we will still have with some resolving of the trade-offs. And yeah, this is an abstract example. It's close to real life, but let's take a look. Only do I see something overcomplicated here, because years ago we had just CSS and we wrote styles like this. And I think that when you only start learning web development, you will learn some basics of HTML and CSS, and you can really understand this code on the right side. Don't you feel that we have missed something important? Sometimes I really miss this simple and declarative CSS code. And I might call it a problems loop. We are trying to solve some problems, but the solution produces a new one. And we try to solve the next problems, and again and again and again. And I think that exit from the problem loop is the abstraction loop. Abstraction loop is an idea from Lee Byron. He talked about it on the React Europe 2019. And this is the way how we can rethink our previous approaches and how we can reinvent some of the best bits from the past, but with a new vision, but with a new syntax or abstraction or like that. And let's take a look again for the last time on this code. It's simple, right? Why don't we write code like this? Actually, we can. We can with Shadow DOM, for example, but it will also have some trade-offs. We can write it in a related way with the field or view, for example. But I also want to mention another one thing here is why we really love React, for example. Because it introduced us state-driven development, and it's really easy to match your state to the component state, to the markup, to the way how components will interact with you. And we introduced the state-driven development there. And I also want to mention the state-driven styling. And the thing here that we can make a simple state-driven development, for example, with React, and simple state-driven styling. And I'd like to introduce the shadow to you. That's an idea how we can write semantic markup and styles and feel the way that it works right. Let's imagine the phone component. And for example, with the shadow, you can easily start with the markup like this. It looks like XML, and with the shadow, you can semantically name your elements like phone, camera, speaker, and so on. And instead of mapping your class name, you can just split your elements to the semantic elements here. And you can always fall back to the text. So by default, all the text that we don't know in browser will fall back to div, but you can specify the text explicitly by the S property. And it became really easy to style elements with the swap styles. So you can just write your styles as it always we could, but this button will be isolated. And it's also easy to map your state to the markup here. And for example, you can map your styles and attributes to the virtual DOM. And Shadow brings Shadow DOM developer experience, but for the virtual DOM. And you can easily compose your attributes and properties and match on the properties and attributes here. So for example, we're still able to use simple decorative selectors in CSS, but there are a lot of things that you can describe, for example, by area attributes and match styles on the area here. And another useful thing is modifiers. For example, we have a model property, a model modifier that is not presented in the DOM. We can use the use namespace here, and this is just the part of specification of CSS and the HTML. This is the correct code. So you can really easily declare some complex things, depends on state, and this code is part of basic HTML and CSS again. So modifiers will be omitted in the DOM node, so the phone element will not receive the model property, and you will care about your valid markup. So this way, we can completely restyle our phone with the brand new model, for example, and split our styles to the different modifiers. And with component selector, you can also write some styles for the component and map your styles to the components too, without additional class names and so on. And let's take a look on the implementation of that phone, for example. We have a styled function which is similar with styled components, for example. And we can write styles in the separate files, for example. We can just put our styles in the separate file, or we can put our styles in the JS file and write them in the markup, but in the render function. But the important thing here is that you can pass your props and some runtime things directly to the render styles without mapping your hired components like styled components, for example. You can just render your state and render your styles too with that state. You don't need a wrapper here. And styles that you render will also be statically extracted. So they will be mapped to the CSS custom properties. And if you take a look on the markup, on the final markup, all the elements will receive the class names with hashes, and the variables and runtime parts will be mapped to the runtime of CSS variables to the root node. So these styles will be isolated too, and they will work only for the that component for the component tree, but it will be still extractable. So all the files that you see, you can extract with separate CSS file, and you don't need to parse it on the client and don't need to render it. And it's really easy to compose styles with the shadow. For example, we can compose that styles with other different styles that we receive from the other components. We can easily get all the styles for the component from the props. And for example, we can inject our styles to the component. And for example, here we can declare our new phone with some new styles and pass the styles to the phone, and it will be completely restyled. And this is the basic idea how shadow and dependency injection works for Yandex Market, for example. Yandex Market is one of the largest marketplaces in Russia with many different products, and we need to style our components in very different ways. So we have many similar but not simple components, and we'd like to reuse our code base as much as possible. We have to have hundreds of A/B tests at the same time, for example. We have hundreds of front-end engineers that need to maintain that code. And basically, how to change components view. We have several options here. For example, we have modifiers. We can set the modifier like color, like theme, like variant, like size. And it's really good to declare the component style and interface, but it's not really flexible. If you need to change something that was not declared in the interface, you need to change the component code and API too. And the next way to do that a bit more flexible way is theming, because you can also declare your theme interface too, and you can split your component properties and API to some of theme and some of component API like props. And for example, you can set the primary color for the component to the theme and get that primary color from the theme, not from the properties. But again, it's more flexible with modifiers. But if your theme doesn't support something, if you need to update your theme, for example, or component, you also need to do some work with your code. And the last one thing is styling. Is the approach that this is the approach that we use at Yandex Market. And this is the way how you can completely restyle the component without code changes. And let's take another one look on our snippet list to our components. They are completely different. It's quite hard to declare by theme. But for example, if we have a snippet list, we can declare that like the snippet list that we will receive our style from the properties, and all of that code you need to write your logic, your basic logic and your basic markup here. And after that, for example, for the market service or for any one other service, you can get that component, register that in your registry. And after that, for example, if you have an application that contains some snippet lists, and in real life there are a lot of snippet lists in the Jeep. But for example, imagine we have that app. If you render that app as default, we will receive, for example, this snippet list here. But if you want to make an experiment, you need to run some A/B tests and, for example, to check that this style is not really good for conversion, for example. And we can just wrap our app with the market provider here and map our snippet list to the duplicated snippet and use the duplicated snippet style. So the styles will be different, but there is no any other code change in the application here. And which is more interesting, I think we can just get the component from another registry, for example, from the registry from the other service, and we can completely restyle our snippet list in that service with styles of the separate service without any code changes too. And you can completely restyle the whole application here, and you can, for example, restyle Yandex Market to the Brindley Market without, again, any code changes here. And it might look like a magic, but let's take a look again on the CSS models here. We have CSS models, we can import that style, and we can map some class names, and yeah, it's really similar for the engineers who works with CSS models. What if we put that style to the props, for example? Yeah, we can restyle with our style some class names, we can restyle our button, we can restyle our sites and all other things. But the problem here is that if you don't consider that your styles might be applied for different states of the component, for example, if you don't pass your class name from style to the icon or to the disabled button or other things, it's quite hard to style it from the other side. And there are some duplications here. For example, we have a button and we have a disabled state that we also need to pass to the style in our solution. And we also, and I also think that the element icon here is more important that this is a span, because it's about semantics, how we can declare our component and styles. And with Reshadow, we can easily receive the clear markup and clear, I think, styles here too. And every developer can restyle the component with the way he really thinks is important. For example, A/B test. And the performance is one of the most important things here because there are a lot of benchmarks, and it's important to understand what we can do with these opportunities. And if you compare that with Reshadow, Reshadow is really much faster than any other solution just because it also works with extracted styles, and it's really effective on mapping the styles to the component state. And there is also a package with Reshadow React, so it doesn't ever need Babel to compile your code. So you can just import the Reshadow React, write your styles, and that styles will be compiled on the client side, but it will still much more performant than, for example, Emotion or style components. And if we will take a look on the 1,000 boxes, the Reshadow is not depends on the way how many elements we need to style. Yeah, there are some correlations, but your performance will not go up with with more complicated applications here. As I said, there are some benefits with semantics, and you can just write your HTML and CSS as you prefer, and you can compose your styles on different themes, and you can inject your styles, for example, for experiments, but you can omit this function because sometimes you don't need that too. And we try to combine the benefits of CSS and CSS together. And yeah, some more things. For example, how we can style the component if we don't want to check the source code of the component. So, for example, with Reshadow, we have static analysis here, so you can just build a table of the elements and modifiers that you can apply, and you can just check that table and apply the elements that you need. And the Reshadow based on the PostCSS ecosystem, so all the benefits of PostCSS you can also apply too. And the Reshadow has zero conflict, so you don't need to start, you don't need to even some setup here without PostCSS or Babel. Yeah, one more thing. Sorry. I was talking about React, but Reshadow works with any component-based solution like React, CLPU, and all other stuff. Reshadow is framework agnostic, so there are different ways how you can apply your styles with different frameworks. So if you are interested in, there are some links that you can use. So finally, I'd like to say that history is repeating, and you also need to remember that all the things that we're trying to introduce sometimes somewhere they were already introduced, and you need to know that history, and you need to understand why that solution wasn't applied at that time, but maybe you can apply that today. And we need to listen to the community experience here. So yeah, the last one thing, tell the way you feel it right. Thank you very much. Any questions? Do we have some time for questions?
Yes, we have time only for 5 questions. So pick them wisely.
Yeah. Yeah. So if you write your styles in the separate files, you can achieve all the benefits of tooling for CSS just because this is just the CSS. So you will have autocomplete on all other things because there is no other language with Reshadow. You can just write your CSS in separate files and that's it. If you use CSS and JS approach, so you write your styles in the JS code. So yeah, there are some problems in different ideas, and with VS Code it's a bit better because we have a styled components plugin, and it will partly work with Reshadow too, because it's completely the same interface here. But yeah, there are still some work that we need to do with CSS and JS. It's the same thing for other solutions like Emotion and style components too, because when they came, there were a lot of gaps in the tooling for the reductors, editors. Yeah. Yeah.
About
That's a really interesting question because we also interested in support of React Native too, and uh, because of abstraction from the HTML, because the shadow introduces some semantic elements and semantic modifiers, there is no really binding between HTML and the shadow. And I think that it's really possible to compile, for example, instead of div, you can fall back to the view or other things, and you can use that abstraction with React Native too. But there is the research, we don't have any working solution at this moment. But I think that you can really write your styles, for example, in separate files too, and compile them to the object styles and use them with React Native. It looks possible. Another one question. Yeah. Uh, yeah. Uh, that's a really good question. So we use Reshadow in our production in Yandex Market, and we use it for building our design system. And for example, some features that I have shown here are completely supported, and we tested them in our production. So there is no magic, and there is no some unknown bugs here at this moment. But it's still alpha because there are some experiments with, for example, style components bindings. For example, we can use the API of style components, but Reshadow under the hood, and we have some experiments with that, and it's not really it's not ready for production. For example, this approach. But Reshadow core, the Reshadow that I shown here, we use in production, and we support that in the open source. So we have some time to support that. So yeah, I think that basic Reshadow things you can already use, and it will work. For example, if you use just the Process plugin and Babel plugin, so you can just apply the styles with PostCSS to the styles that you already wrote. Just you have the CSS file, right? You have some PostCSS here, so you can just add another one plugin with Reshadow and write styles instead of class names, write elements, and that's it. And with Babel, you can just add the Reshadow Babel plugin here, and instead of class names, you can just start to write your elements, and it will work because there is no really complex things under the hood. But there is also the next version of Reshadow with some interesting approaches, and we are working on it. So I think that with that version, we will release the stable version, and we will start with semantic versioning there. Thank you very much.